Hello, students. Today I'll be talking about circuit analysis technique, which is a node voltage analysis. Okay, one of the reasons for this one is how do we handle if we have a large network? Well, do we need to use a circuit analysis technique or computer simulation? If computer simulation, how do we self-correct if anything goes wrong in the simulation? For example, how does the UK electricity network analyze it? For it is obvious that it will be computer-based. However, can we do equivalent circuit analysis method? We must be able to do the analysis hand calculation analysis. So, for example, now it is 1,500 nodes and 2,500 branches, but we cannot use this one hand calculation every minute, but we should expect doing by hand calculation the outcome. So if each time there will be a line or transformer or any other device, such as, for example, like cables, say, or bus bars, out of service, then this will result a change of configuration in per minute, per second, or hour, or whatever. So then the analysis technique is required. Well, how do we do? We start with the basic one. Okay, so we must be able to do some circuit analysis technique. So that's the reason why, for example, how the National Grid handle the Great Britain network analysis technique. Of course, we use the software, specialized software, but to begin with, we must be able to do the basic circuit analysis technique using hand calculation. Okay. So before we doing the nodal analysis technique, we must be able to do understand the basic definition. So what is a node or node point? Well, a node is a junction or a connection point. Okay, so where it connects two or more elements. For example, A or node A connects the terminal between the voltage supply and resistance R1. Essential node is also defined as when a circuit connects more than 3 wires. For example, node C and node E connect 3 terminals. Of course, node D is connecting R2 and R3, but we can also consider as a node, but because it is within the two essential nodes. Say, for example, we can treat as an essential node, but in reality it's not. Okay, so a node voltage also in a node voltage, the voltage rise from the reference node to the non-reference, where a nodal analysis uses the first principle of Kirchhoff's current law. Okay, what it means is whatever we have a current in here, if this is current is entering, then this must be equal to this two currents leaving. Okay. So assume that let's consider this circuit, and this circuit, the voltage are measured in each nodes. I have node 1 here, node 2, node 3, and node 4. Each voltage, measured voltage are here. 3 volt at here and 1.5 volt or this body at here. Okay. And for obviously 12 volt at the source. So therefore, the voltage at node 1 is 12 volt with respect to the reference in here, that is grounded, okay? And then for voltage at terminal 2 or node 2 is 3 volt, and so on. So once we know the voltage, then it is easy to calculate a current across the branch, either I1, I2, I3, or I4, or whatever, I5, okay? Because I is equals to P over R, Ohm's law. So if we know the voltage across the branch, V over resistance will be the current across each branch. Okay. So, for example, if we look at the voltage across 9 kilo ohm resistor, this voltage is the difference between the supply voltage or source voltage and VA. the voltage across terminal 2 or node 2. That means 12 minus 3 is 9 volt. Okay, and then of course we can apply this one Kirchhoff's voltage law to make it equal to 0. In a similar manner, we can find the voltage across V3, which is VA minus VB, the voltage difference, same as a V1, which is VB minus VC. And then from that, we can calculate the currents in each resistor. As Borod mentioned that I1, for example, in here will be V1 divided by 9 kilo ohm, where V1 is 9 volt, 9 divided by 9 kilo ohm, that is 1 milliamp, isn't it? Okay. Okay, and then I3, which is this one, will be V3 over 30 kilo ohm, where V3 is the difference between VA and VB. So 3 minus 1.5 is 1.5. 1.5 divided 3. So you have to calculate it. Okay. And then I2, I4 is easily calculated as well. The main thing is we have to be able to measure the voltage across each resistor. Okay. So this is just the measured voltage using a multisim software. Well, multisim software is nothing but here it looks like this. So as you can see, 12 volt, and then on here, each voltage across each nodes. Well, we can also measure a voltage across here as well, across this 9 kilo ohm resistor. I'm going to click in here. So for example, then I'll run it, for example, 9 volt. So if you see here, the voltage is 9 volt, as what we calculated. So the difference between this 12 minus 3, 12 minus 3 is 9 volt. Okay. So yeah, so how about mathematically? How do we do the nodal analysis methods? So for example, like if we have a voltage in here, we have a voltage in here, a node 1 on here, okay? At node 1. Well, if we have here, then the difference between this and this, which is V1 minus, if I put V1 here, V1 minus 50 divided by the resistance, which is the current in here. Okay. So this will be the current in here. Okay. And you must establish this 3 branches. Okay. So 50 minus V1 minus 50 over 5 plus V1 over R2, which is 10, plus V1 over 40, because there is no resistor here. So this, even this connection point can come into this. And then of course, minus 3 amp in here. Okay, so that V1 is 40 volt. So this voltage across here is 40 volt. And then I check with the multisim software. So my voltage in here is, that is line and the neutral in here basically, means then 40 volts. Okay. So if this is 40 volt, then we can calculate the branch currents. Because IA, we have this coming to that side, and then IB, and then IC, and then of course this is 3 amp. So to do that one, IA is, 50 minus 40 divided by 5, 2 amp. IB is in here, V1 divided by this resistor, 40 divided by 10 is 4 amp. And then IC is also 40 divided by 40 is 1 amp. In other way, what is in is equal to what is out. So there's two current, 2 plus 3, which is plus 3 amp, which is 5 amp, are equal to this IB plus IC. If we add this one, then that is 5 amp. Okay. Yeah. So there's two current entering the node are equal to the two current leaving the node. So based on nodal voltage method, we can calculate the current. Well, let's check how the measured values are indicating. So if we check in here, 40 volt in here, which is the same as in here because they are in parallel, the current I1 is 2 amp, and then I2 is IB, or sorry, IA is 2 amp, IB is 4 amp. As you can see, IC is 1 amp only, and then of course this current is 3 amp or minus 3 amp because it's entering the node. Okay. So yeah, and then from that we can calculate the power. Because I square R across here, V times I, 50 times 2, which is minus 100 watt, which is, it means it's delivered. Okay. And then the rest, if it is positive, it means it's observed. Okay. Well, we can see how power is measured in here. If you look on here, sorry, let me just stop this running and allow me to run in here. So if I run this one, you can see the current measured in series. Okay. And then if I can measure the power basically, and here, for example, if I click in here, it is just, as you can see, minus 100 watt. It means it's delivering, it's providing source to the network. Okay, and then if I measure the power again in here, it is 160 watt. It means it is observing power. It's positive in this case. Okay. And similarly, if I measure power across this resistor, yeah, 40 watt as well. Okay. So if the positive power means it is observing basically, it's just receiving power. It's nothing. Okay. Okay. So this is the simplest way that multi-sim software can help us to build a circuit just for verifying our calculation. But the main thing is, if we measure the voltage using a node voltage method, then we can calculate current across the branch. That is the main message of this presentation. Okay, thank you.